Before I start, I tend to be a bit thought-provoking. It's not meant to be offensive. And if you see my presentation later on the website or in printouts, there's a lot of hidden slides that I just will skip for the purpose of this this presentation. But there's some more background information in there. So, a little bit about me. I've been a water infrastructure planning manager in North Shore and had a lot of other urban related roles. Only recently I converted to consultancy, but I still think and act a lot like a bureaucrat of local government, I think. Urban water management still causes a lot of problems, and I have to apologize, there's not many local pictures because my experience goes more somewhere else. But we have flooding, we have pollution, sediments coming from urban areas, we have overland flow, and we have a lot of stream deterioration as a consequence of urban development. The consequences of those are multiple in, call it the quadruple bottom line, environmental, social, economic and cultural. The point I'm trying to make here is that the current generation of plans and strategies has actually failed to make it work to protect water quality. But having said that, there's still lots of bits of urban water or water receiving waters from urban activities that are really worthwhile protecting, and I think that's really important to realize. And even I suppose I said before, the ones that have been deteriorated we need to improve. So this is a bit of a contents slide, so skip that or come all back. Briefly touching on water supply, it's not often perceived to be a part of the water quality issues, but there's still a few little things that touch on water quality. So you've got water allocation. Are there more sources needed? Are they polluted or will they be polluted in the future? Think Havelock, think what happened to water care past the storms 1 or 2 months ago. So there's still a lot of water quality links, I suppose, is a way to say it. Water demand management, I would say New Zealand is way behind. Our water consumption is probably double about what it is in Western Europe, and I think that's really sad and could be improved. And there's resilience. Often a lot of councils, depending on one little water source, or there's one pipeline, if you have an earthquake or some natural disaster and that's taken out, did you think about what happens then? Wastewater leak. They let water in through downpipes and gully traps and leaky sewers, but also they let water out those leaky sewers, which consequently is translated in exfiltration. Both led to pollution. If we're talking about overflows, we have the nicely controlled overflows, engineered structures, normally close to pumping stations where the system is surcharging, they overflow into receiving waters, but there's also lots of uncontrolled overflows, pumping manholes. And you see some pictures there that show that. The frequency varies a lot. In my experiences across New Zealand, you have systems that overflow less than once every 10 years, and you have overflows that happen more than 50 times a year, and anything in between that. The water quality effects are very difficult to measure because it's very intermittent. If they discharge in streams, I would say it's plug flow, so by the time you're there to sample, it's gone past and ended up somewhere else. And if you look at the frequencies, it's much more frequent than flooding. So my statement would be, every time you have a flooding event caused by rainfall or by sea level, it's very likely that flood waters will be polluted by wastewater. Very likely. And then obviously you've got all the nutrients and BOD pollution coming with wastewater overflows. That's probably more important for streams and stagnant waters and lakes and the like. Over the last couple of years, I've noticed that a lot of regional councils do not always require discharge consent for wastewater overflows. yet it's the single biggest point source in a town, in a city. So I'm a bit confused by that. I think it's really odd. They should be regulated and should control this discharges as well as any other polluter. Treatment plant discharges are a little bit different. They're obviously not intermittent, they're 24/7, and they're kind of in hand. I mean, there's obviously always room to improve, but typically they're consented. There's processes in place, there's monitoring programs in place, as we've seen in the previous presentation. I think suffice to say that wastewater discharges are generally considered culturally offensive, and we've seen the first. We're talking about the leaky sewers. It's very difficult to measure. Inflow and infiltration is the jargon that's normally used. I've done a lot of work in that space, and you can do calculations. You can provide heat maps to find your most leaky areas, and you can get on to fix them. There's two types of renewal. One is condition-based, which is when your sewers give up structurally, and there's performance-based when they leak. And I would argue that you need to integrate the two types of renewal just to be more cost effective. There's multiple tools to combat inflow and infiltration. Obviously, reduction inflow and infiltration is the first thing you think about, but it's extremely expensive and the outcomes are quite uncertain. So quite often, councils result to basically build storage or more capacity to convey those high wet weather flows. Another point I want to make is councils have to fund depreciation. It's a bit of a financial thing, but they have to fund, and depreciation is to fund renewal. They typically pooled across councils, so it's used for something, but more often than not, I see that the amount of money councils spend on renewing their assets is way lower, the budgets, than what they actually depreciate. So what I'm actually trying to say is there's actually money there that you can use to undertake sewer renewal. Improving performance, and that might be something we want to talk more about in the next day or so. There's only so much you can achieve, and I've been in meetings and projects where you start with a blank sheet of paper and say we want no overflows, but if you actually start calculating what it's going to cost to get to from where you are here to where you would like to be, and this is the North Shore example, and this is a project that it's only recently completed, a little town in the north of New Zealand. At some point, by throwing more money at it, you can actually get a really marginal return. So I think it's really important, but if you set yourself standards that they are affordable, and that people actually realize that by asking something that's way out there, that's going to cost the community a lot. I think that's totally in keeping with the best practicable options of the RMA, and I think that's almost a process that should be compulsory to go through to actually set yourself a standard, because it's just good practice, I suppose. About bacterial pollution, touched upon before. Point I want to make is we've done a lot of sampling in the past about this was particularly enterococci. This was a grid along a beach, ankle deep, knee deep, hip deep, and whether you took a sample here or a sample there, I sometimes said you might just as well use a random generator. It's very random, and I'm a bit concerned that people put a high reliance on one-off sampling because of that. Can we predict? This is some plume tracking that I've managed a while ago. I think if you want to find out if you discharge from here where the water or where the pollution is going to go, yeah. But if you're trying to predict enterococci levels, for instance, to the last digit, I really think that goes beyond what we can and should do. Urban point sources, I don't want to spend too much time on that. I think typically it's all in hand. It's all sort of common practices to do that sort of control and enforcement. But also think, sometimes I wonder whether road runoff is a point source or not. The quality of stormwater, I think it's really important to understand the difference between stormwater and wastewater. Sometimes I say if once it's in the pipe, there's very little you can do about it anymore. So a stormwater network manager hasn't got a hell of a lot of control on the fate of the water quality of stormwater. Sure, you can put wetlands and treatment at the end of the pipe, but a horse is bolted largely by land use. So we really have to think land use, and we really have to connect land use to water quality outcomes, and stormwater being in the middle of that. Wastewater networks are quite simple. I mean, you can almost compare it with a power system. You buy some water, you pay something, it's closed pipe. You're kind of totally in control-ish as a network operator. With stormwater, it's not the case. So, point is that stormwater management needs a whole different set of controls in your water quality strategy and your plans. It's not the same thing. It's easy to talk about a network discharge consent and be done with it, but it's totally different. Trying to illustrate so the attention, I suppose, related to stormwater in terms of frequencies. Traditionally, we're talking about sort of flooding, which was like 10 years plus. Stream health is probably in the lower echelon of this is actually return periods, 1 in 100 year, 1 in 1 year, and lower. If we talk detention, we often talk about 1 in 2 years. Overflow sitting somewhere here, treatment plant sitting somewhere here. So if we talk water quality and stream health, we're talking about everyday storms. And what's happening in everyday storms, if this is your 1 in 2 years somewhere, your volume only goes up, or your flows only goes up by 2-3 times compared to what was there before urbanization. If you talk about your sort of more frequent storms, you go up to 10 to 20 times difference in flows, and that's largely determining your health of your ecosystem. It's not the storm that happens once every 100 years. So if we're talking about stormwater management, you have to keep that in mind. And I think building detention ponds, for instance, the old Auckland TP10 only addressed a peak storm to get the storms down below this level, and actually did nothing about that particular part of the curve. I made the point already. I'm not sure whether what water quality is in scope or out scope in this particular workshop, but the link is there. There is a water quality component. Flooding water will be polluted, and by wastewater, and stormwater in itself is polluted as well. In Auckland, regional plans did put requirements on flooding. I'm not quite sure what the scope is here. Overland flow. These days we got technologies that you can easily map overland flow based on your LiDAR, so you know how the water is running off the hill and it ends up in your streams or in your floodplains. Anecdotally, we have more habitable floor floodings coming from overland flow than habitable flows being flooded in floodplains. So something that's quite often kind of not really looked at, but it's really important. And certainly when you start thinking intensification, like in Queenstown or Dunedin, people start building in places they normally didn't, because for a very good reason, because there's water, and now they're starting creating problems, so water shooting off a driveway and straight into your garage or your front door. Stream loss. Typically during development, we still blitz the stream environment. I've been involved in a big structure plan development that went all the way through the Environment Court, where we tried to protect headwater streams. There's now case law. Environment Court actually said, yep, that's what you need to do, because you can't have a healthy mainstream with all its headwaters cut off. So that's really important. Also, if you think about piping, we call it piping, but I would actually prefer the terminology reclamation. There's mainly one reason why we pipe streams, and that's just to get more land that we can develop. There's no other reason. Sometimes there's access for a car, but you only need a little culvert. You don't need to pipe a whole stream. So, and nature shaped the channel over many thousands of millions of years to put a pipe in it and say, as an engineer, I'm a similar engineer, by the way, just say, well, that carries a 100-year flow. You're still asking for problems, because there will be a point that this pipe will not cope and will overflow. And there's always the 1 in a 101 year storm, and you need to know what's happening then as well. So we need to talk about values in urban environment, and I think that's quite topical. We'd have to think about what values we can achieve there, whether it's realistic to expect a pristine quality in urban environments. I've had some big discussions with regional councils in the past, where the council said there's no point throwing money at water in urban streams. It's much more effective to use it somewhere else. I would disagree with that. I think there's certainly values there, and there's an amenity value and a learning value and an ownership value, and there's it's your taxpayers. You have to grab money off them. So at some point you have to motivate them to actually support that sort of approach. So I think it's really, really important to look after your urban streams. Cumulative effects. My statement would be that a case-by-case approach has failed in the past. Again, in that same environment court process about the Long Bay structure plan, the developer said, we'll comply with whatever you want us to comply, but we do it consent by consent by consent. We'll look at the effects, and if they're more than minor, then we'll mitigate. And we have no problem with low impact design. Well, we've tried that process over many, many years, and the streams in those areas have all deteriorated. So that process really hasn't worked. And I can go into technical detail why not, but it hasn't. So we have to look at cumulative effects at a catchment scale, and we have to translate the catchment plan information into structure plan requirements. At that level, that's where we need the rules. Case by case is basically death by 1,000 cuts. That's all I can come to. From an asset management point of view, we use natural streams as part of our assets. They drain our water, so we should treat them as such. They actually should be in our asset management plans. And by doing that, you force yourself into considering what you need to do to maintain that drainage function. And obviously then you have to link it to water quality and ecology and so on. But it's important to recognize them as such. There's also a little financial aspect to it, and I think Christchurch did it many years ago. Your grey assets depreciate, your natural asset appreciates, so you might get a bit of more balance in your books as well by doing that. Dealing with growth, you can't unlock growth randomly. There is an expectation, certainly from the development community, but from many councillors as well, that developer A wants to go there, and developer B wants to go there, and they want to be councils to be everywhere to provide the infrastructure. That's just not working. It's unaffordable. So you need to plan ahead. And I would actually argue a cap and release type of mechanism by saying, okay, well, we're looking 10, 20, 30 years ahead where we want to grow, but the way we want to manage that is in a cap and release fashion, so the infrastructure can keep up with growth. I'll skip that, you can read. So traditional approaches haven't worked. So what's another way of managing stormwater? Well, I call it water sensitive urban design. Other people call it low impact design. The only thing we need to remind is if people use those words, they think about rain gardens or rain tanks or something like that. It's way more than that. It's almost a design philosophy. First, you start at your design level, at the structure plane. You want to retain your stream network. You want to minimize earthworks. You want to minimize compaction. You want to stay out of the floodplains. Those translate in what I would call a green fingers approach, because the floodplains would normally sit around your stream, so stay away from them. And it gives you a huge opportunity to actually create a bit of amenity and recreation as well. And then you start looking at minimizing impervious, and then you're looking at treatment. So it's a whole combination of things that in the plans we need to spell out that that's the process people have to go through before they revert to traditional, if that's still an option. Having said that, it needs to be fit for purpose. You can't put the same requirements on an area that discharges straight into sea compared to an area that discharges into a sensitive environment and anything in between. And you have to look at quantity and quality. So you can do all sorts of kind of geometric kind of analysis and we've done that many times, and it's kind of complex to a degree, but it can be done. It has been done, so it's not hard to kind of translate the desired fit for purpose into particular rules. There's lots of myths around water sensitive urban design. I'm just losing the slide. I think in summary, I would like to say internationally you see it more and more and more accepted. There's people saying it's expensive. It's actually not. There's increasing signs that it's not. It needs an economy of scale. Long Bay, for an example, the cost for bioretention halved within 2 years because they built lots. So if we make bioretention business as usual, then you will see the same effects as what happened 150 years ago with pipes. You build lots, it becomes cheaper. But it does require some specific attention to the detail in the design. So you need qualified people that actually do it. Moving on to integration, which is kind of water sensitive urban design. We have to keep in mind that fixing problems retrospectively in stormwater is extremely expensive, if not impossible. Getting properties out of floodplains is expensive. So I think there needs to be a discussion, and I've been part of some initial projects like that. We have to look at what I would call affordable level of service. We very easily say, oh, no habitable floors in 100-year floodplain. Well, you might not be able to do that. It's just too many and too expensive. So you have to really think about, and you took the same approach as with the wastewater example I did. You do a cost benefit and you say, this is what we can afford. Because I think we're promising our community too much sometimes. I would say, certainly in redevelopment, to take an opportunity-based approach. When there's a new road, when there's a redevelopment, when there's a new greenfield development, that's the opportunity to do your stormwater management well. If you do those projects in isolation, they're extremely expensive. And we need to think about cross-crediting. It's proven to be very hard in New Zealand because of the way we write plans. But you can think about, if you improve stormwater better than baseline or something like that, you can build an extra story or something like that. I don't know. But there's some really good international examples around that enable you to do that sort of stuff. Moving on to green infrastructure. Green infrastructure is, it goes beyond just for stormwater reasons. That's all it is. So we're looking at multiple benefits to implement green infrastructure, and goes across the whole quadruple bottom line. And you're creating a sponge city. You're trying to mimic nature by doing that. There's lots of types of incentives you can think about, but that multiple funding streams is something that I kind of like as an easy way. Once upon a time I tried to convince North Shore Council to start with an impervious area tax. It never survived, but it's one way of doing it, I suppose. And you really have to wonder, there's lots of landscaped areas in urban space where we seem to elevate the level of your landscaped areas above road or footpaths. So we almost deliberately don't want the plants to receive and trees to receive any water. I sometimes do not understand why that's the case. You can make it a bit lower. You can use, and it doesn't have to fully comply with the bioretention specifications, but every little bit helps, and that would be so great if we could change our mindset doing that. Just a few other little parting comments. There's a lot about, I always use the phrase existing abuse. There's an existing use rights in the RMA district plan level that prevents retrospective or clawing back, I suppose would be a word. There are ways to do that, but it needs cooperation between regional and local councils to give effect to that, because you have to do that at the regional plan level. Precautionary approach. I'm really surprised why urban water management doesn't use that. We seem to be kind of really at cutting edge and never take a safe approach. So I think we need to think about how we use that. Our assets need to last 100 plus years. Our plans only look ahead 10, 20 years. So there's nothing. Well, ideally we need to project further and see how big or how our assets should look like going forward. And my understanding is, although I've been through lots of plan changes, I mean, sure, some developers will fight some of the detail and find it too expensive, but at large, the biggest frustration is with the uncertainty. So if developers go to council and the council consent engineers don't quite know how a rain garden should look like or aren't used to it, and they're getting pushed back, and so the planners don't agree with the consenting people, and there's all sort of frustration. I think that's where more the frustration comes in, and obviously with the time lost on that, a lot of developers just tell me what to do and get on with it and give me the consent. So in recent years we developed practice notes for North Shore, but now for instance for Tasman and Nelson they're almost complete. And it's like a rubber stamp. If you do it this way, you get rubber stamped. I just want to emphasize there's a public and a private. So if we're talking assets, like for instance wastewater, 50% of your assets are actually in private. So you have to think about how you address private, and you can use a regulatory stick approach to that. I have found that a more amicable way of dealing with overland flow and wastewater overflows and that sort of stuff is much more effective, but it needs management and political will. And yeah, worth a discussion. And then there's regulatory versus non-regulatory. I'm not quite sure how much we will talk about non-regulatory because we're talking ultimately it's like plan changes, but I would argue that a non-regulatory approach is very advantageous. I was actually kind of a regional council function before I moved to New Zealand. We didn't move on water quality in urban areas at all. Suddenly, it was actually my initiative. I did a 50-50% on some of the water quality components of the plan making, and suddenly everybody did it. And you're grabbing money of the same taxpayer, so it actually doesn't really matter who of the two pays. And it actually worked like a dream, and that's kind of a non-regulatory incentive type approach you could think about. Freshwater management. Fiona presented at the Three Waters conference in October, and my observation was it was great to do that, and I've talked with Fiona. I saw many asset managers kind of looking a bit confused because they still don't quite know what's going to happen to them, what the consequences are. Because the MFMV traditionally talked a lot with the regional council, but hasn't actually communicated a lot with the local ones. This is awesome, this workshop, because this is something that you can kind of incorporate in. But it's important to take them along and figure out how we can achieve some of those water quality outcomes we're looking for. And there's many other things we can do together. I don't think it's helpful building Chinese walls and having a them and us, which I have experienced elsewhere. Yes, you need an environmental watchdog. I'm not a big I'm not in favor of unitary councils. I've seen some of the consequences of that, but there's many ways to work together. And a simple example is just sharing data. Why don't you build geometric networks that link streams to pipe networks, to overland flow, and so on? So that there's stuff you can do together. I'll skip that. So last, which kind of tells a little bit about my frustration over the last years. We seem to fight the same battles over and over again across the country. It's extremely expensive. I'm a hearing commissioner as well. The amount of repetition and arguments about the same things in another place is overwhelming and frustrating, and it's costing New Zealand a lot of money. So I think once best practice is confirmed, we just have to get on with it and put it at a higher level, like in a regional regional plan, or even at a policy statement, national level. Thank you. Any questions? Oh, no questions. Huh?